Okay, so we're going to try to tie what we did yesterday, which was our slope field stuff, right? With what we're doing today, which is separable equations. And I just want to start by looking at this slope field, x minus 1. If you notice, for an x value of 1, it would produce 0 for the slope field. So therefore, wherever I have a value of 1, I'm going to have a slope of 0. Wherever I have an x value of 2, I'm going to have a slope value of 1. And wherever I have an x value of 3, I'm going to have a slope value of 2. As I back up 1, negative 1, negative 2, negative 3, negative 4. Good? Okay. On the AP exam, they will ask you to draw a solution for y of 0 is equal to 1. And what that means is it goes through the point 0, 1. So I'm going to draw 3 graphs here, and you try to tell me which one is the correct one. The blue one. Okay, the green one goes against the slope field, but it does pass through 0, 1. The black goes with the slope field, but it doesn't pass through 0, 1. The blue one does. Do you agree that that's a parabola? Watch what happens when we find what's called the general solution. So dy over dx equals x minus 1. What that means is this, is dy over dx equals x minus 1, or dy equals x minus 1 dx. So what that means is that I multiply the dx to the other side. Are you okay with that? In order to get rid of the dy and the dx, I take the integral of both sides. Now, this is like a 1 dy. Let's do the right side first. What's the antiderivative of x? And what's the antiderivative of 1? Right? And then you have a plus c on the end, right? Well, instead of, so now this is dy, the antiderivative of 1 dy is just y. This is what we call our general solution. It's a parabola that would have a constant. So the difference between the blue one and the black one, these are both graphs of x squared over 2 minus x plus c. It's just that one of them satisfies the initial condition. We would call that the particular solution. So when it says determine the particular solution, we say y is equal to x squared over 2 minus x plus c, and we figure out what c would need to be in order to satisfy the coordinate 0, 1. Exactly. So 1 goes in for y and 0 goes in for x. C is equal to 1. So now that you know c is equal to 1, you can write y equals x squared over 2 minus x plus 1. This is the particular solution. Not too bad? Okay, so that connects with what we did yesterday. The problem is a lot of times with separable equations, some of them get rather challenging. They're tough. So it says determine the general and particular solutions for the following. Now we have dy over dx is equal to x over y. Y of 1 is equal to 2. So notice when I multiply both sides by dx, I get dy is equal to x over y dx. And now to move the y, I multiply both sides by y. So y dy is equal to x dx. So on the AP exam, just for separating the variables, you'll get a point for doing that. Another thing that you get a good point for is appropriately taking the antiderivative. In order to get rid of the dy and the dx, I take the antiderivative. Do you know what the antiderivative of y is? Yep. Now, some people get frustrated because we add a constant for the x's but not for the y's. I want to be clear about what's happening. If you had y squared over 2 plus some constant is equal to x squared over 2 plus some other constant, like when you subtracted that constant over, wouldn't that just be, some other constant then? Like, the constants just accumulate, right? So you don't have to put them with both sides. You could just put them with one. So, in the general solution I solve for y, I want the y value solved for. So I multiply both sides by 2. Y squared is equal to x squared plus a constant. 2 times a constant is still a constant. And now we square root both sides. And we get y is equal to the square root of x squared plus c. Now, some people wonder, should it be positive or negative? Well, it looks like the y value is positive, isn't it? So that's why I use a positive y and not a negative. So we have positive 2 is equal to the square root of 1 plus c. Yeah, so this is the general solution, Jack. And then y equals the square root of x squared plus 3. That's the particular. Not too bad. Okay, let's get a little bit more challenging. Notice how the x's and the y's are switched now. So if I divide both sides by, or I'll multiply the dx over, I get dy is equal to y over x dx. And then if I divide both sides by y, I get dy over y is equal to 1 over x dx. You okay with that? So dy over y is the same thing as 1 over y dy. Is 1 over x dx. So in order to get rid of the dy and the dx, I do the integral of both sides. Do you know what the antiderivative of 1 over y is? Remember that? What's the antiderivative of 1 over x? Now we want to get rid of the natural log. I don't know if you remember this, but if we had an equation, say the natural log of x minus 1 was equal to 4, and you want to solve for that, what you did is you created a base of e. And you said x minus 1 was equal to e to the 4th. Do you remember that from pre-calc a little bit? No. So e and natural log are inverse operations of each other. Kind of like, so if you had e to the natural log of 4, those would cancel, leaving you with just 4. If you had natural log of e to the 4th, those cancel, leaving you with just 4. Natural log and e are inverse operations. They make each other go away. So now that we've kind of primed your memory there for that, we are going to get rid of our natural log by creating a base of e. And what we have is, that goes away, we're left with the absolute value of y is equal to e to the natural log of the absolute value of x plus c. Now, I'm going to do something else here. Again, this is just part of the learning that people get uncomfortable with a little bit, but there's different tricks, and this is a trick I'm going to show you. Would you agree that x to the 5th is the same thing as x squared times x cubed? That that 5 is simply just 2 plus 3. So if you look at that property, here I could take the absolute value of y is equal to e to the natural log of the absolute value of x times e to the c. So I separated it into two bases. E is just a number like 2.1 or 2.718. So if you take 2.7 to a constant, you're just going to get another constant, aren't you? So this turns to a constant times e to the natural log of the absolute value of x. E to any power is going to be positive, so therefore the absolute value can just become y. And c times e to the natural log of x, those cancel, I just have the absolute value of x. This is the general solution. I'm now going to find the particular solution. The particular solution is the coordinate 2, 2. So if 2 equals c times the absolute value of 2, what is c in that scenario? 1. So if you plug 1 back in, you get y is equal to the absolute value of x. This is the particular solution. A little bit more involved, huh? I think that the next two are going to go pretty well. That's the toughest one for people to kind of get used to. I wrote this one incorrectly. My apologies. It should be 2e to the x plus y. And so if I multiply both sides by dx, I have dy is equal to 2e to the x plus y dx. I have to find a way of separating this y from the x's. Notice I don't have separation of variables yet because I have a y that's paired there. So I'm going to write this as dy is equal to 2e to the x, e to the y, dy, or dx. Ugh. Now I can get rid of that e to the y by dividing it over. And I get 1 over e to the y dy is equal to 2e to the x dx. Isn't 1 over e to the y the same as e to the negative y? I've now completed my separation of variables. Do you remember our next step? Yep. Let's do the right side first. Do you know the antiderivative of 2e to the x? And the antiderivative of e to the negative y, that one's not as easy because there's a negative sign, isn't there? And if you did substitution, like we just talked about, you end up with negative e to the negative y. In order to find my particular solution, or general solution even, I have to solve for y. So I have to get rid of the negative and the e and the negative. I'll get rid of the negative first. So I have e to the negative y is equal to negative 2 e to the x plus c. The way I get rid of e, do you know how you get rid of e? Good. Natural log of both sides. And I have negative y is equal to the natural log of, I'm going to write it as c minus 2e to the x. And now I get rid of the negative by dividing by a negative. Get y is equal to negative natural log of c minus 2e to the x. This is the general solution. I would like to find the particular solution. What do I do to find the particular solution? Zero, zero, so 0 equals negative natural log of c. And then what is e to the 0 power? 1 times 2 is 2. So in order to solve this, we just have to know the natural log of what is 0. The natural log of what is 0. And I just want to make sure that you guys understand what that means. If I wrote this, e to the 0 is equal to 1, everything that you write in log, so for example, say 2 cubed is equal to 8. That's the same thing as log base 2 of 8 is equal to 3. Okay? So if I write this in logarithmic form, it's the natural log, so base of e of 1 is equal to 0. So just like you said, e to the 0 is 1, that's the same thing as the natural log of 1 is equal to 0. Those are synonymous statements. So if I want this to be the natural log of 1, so I want to be the natural log of 1, c would be 3. Very good. So c is 3, so therefore the particular solution is y equals negative natural log of 3 minus 2 e to the x. That's the particular solution. You hanging in there? Let's do 2 more. We'll talk about where we're headed from here. This one I'm going to multiply by dx. I get dy is equal to x squared y dx. I'm going to divide by y or multiply by 1 over y. 1 over y dy is equal to x squared dx. Separation of variables gets you a point on the AP exam. Now what? Good. Natural log of the absolute value of y is equal to? Good. X cubed over 3 plus a constant. Now what? Good. Create a base of e. That's going to get rid of the natural log. And e to any power is going to be positive. Agreed? Good. Get rid of the absolute value. E to the x cubed over 3. And instead of plus c, I'm going to write it as times e to the c. Well, e to a constant, what can I do with that? Constant out front, very good. E to the x cubed over 3. This is my general solution. Great job. I want to find the particular solution. So I plug in 0 for x and 4 for y. So that's going to be e to the 0 power. What's e to the 0 power? So 4 is equal to c times 1. What is c? So y equals 4e to the x cubed over 3. That's the particular solution. Still good? Yeah. Good. Let's do the last one. A what? Oh, I see. Did I make a mistake? Okay. Yep. Traditionally, we put the 4 in front so it's not confused with something else. Yep. All right. This one. Notice I don't have any x's. If I divide both sides, so first of all, I'll multiply both sides by dx. So I get dy is equal to 2y minus 1. dy is equal to 2y minus 1 dx. And as I separate these, I'm going to divide both sides by 2y minus 1. So 1 over 2y minus 1 dy is equal to just 1 dx. Now, that 1 is just because we have 1 dx. It's not like this minus 1 stuck around or something like that. That's the separation of variables. Now we take an antiderivative. Let's focus on the right hand first. Antiderivative of 1 will produce what? Plus my constant. And then when we look at the left-hand side, I am going to carry out substitution here just to make sure nobody gets lost. The integral of 1 over 2y minus 1 dy, we just got done doing this as a class not too long ago. And we said that in this case, u would be equal to 2y minus 1. So therefore, du was equal to 2 dy. We don't have a 2 dy. So we multiply by a half, and we get that 1 dy. Are you okay with that? So I got 1 over 2 times the integral of 1 over u du. That's the antiderivative we're computing. What's the antiderivative of 1 over u? Yes, so 1 over 2 natural log of 2y minus 1, putting those absolute value signs around it. I got to get rid of the 1/2. So natural log of the absolute value of 2y minus 1 is equal to 2x plus the constant. Now what? Yep. So e to any powers could be positive, so I could write it as 2y minus 1 is equal to e to the 2x. A constant out front, good job. I add the 1, and I get 2. Y is equal to c times e to the 2x plus 1. And I divide by 2. Y is equal to c e to the 2x plus 1 divided by 2. This is the general solution. What do we do to find the particular? 0 for x, 4 for y. So 4 is equal to some constant. E to the 0 is 1. So if I have 4 is equal to c plus 1 over 2, c, I'm going to need 8 divided by 2, so c is going to be 7. So y equals 7 e to the 2x plus 1 over 2. This is the particular solution.